Solve the following equation for x, finding all solutions where x is an element of 0 to 2 pi. So the equation is cos squared x plus cos x equals sine squared of x. In this example, you can see that the equation consists of two different trig functions. And when we solve this by hand, the most convenient way to do that is to make sure there's only one trig function present. So just cosine or just sine. So as we have both cos and sine, we need to get one in terms of the other. And because there's two terms involving cos, but only one involving sine, what I'm going to choose to do first is change sine squared of x into an expression in terms of cos. So the Pythagorean identity says that sine squared of x plus cos squared of x is equal to 1. Therefore, we can rearrange this to get sine squared of x by itself. So sine squared of x, which is this term here, is equal to 1 minus cos squared of x. So that's what we're going to put into the equation instead of sine squared of x. So our new equation is cos squared of x plus cos x, which is just the left-hand side, is equal to 1 minus cos squared of x. And this here has come from this part here, the equivalent cosine expression for sine squared of x. Once again, we can see that there's a cos squared term, a cos x term, and a constant term, which indicates that it might be a quadratic equation in nature. So what we're going to do is we're going to get all terms on one side and get it equal to 0 on the other. So adding cos squared of x to both sides gives 2 cos squared x plus cos x, and then subtract 1, and that will equal 0. And now to make this a little bit easier to deal with, we're going to let capital A equal cos of x. So this just reveals a quadratic for us, and it's going to be 2a squared plus a minus 1 equals 0. And now what we want to do is factorize this so that we can use the null factor law to solve. So if you were to factorize 2a squared plus a minus 1, you'd find that the factorized form of that is 2a minus 1 multiplied by a plus 1, and that factorized form is still equal to 0. Using the null factor law, we can have 2a minus 1 equaling 0, or we can have a plus 1 equal to 0. However, we know a is just equal to cosine of x, so we can substitute that back in, which means 2 cos x minus 1 could equal 0, or we still have cos x plus 1 is equal to 0. Rearranging this so that we've just got cos by itself, we're going to solve cos of x is equal to positive a half, and cosine of x is equal to negative 1. So with these two equations in mind, we're going to go over to the unit circles. And the first one we're going to deal with is cos x equals a half. So there's three exact values that we need to know for sine and cosine. And one of them is that if we have pi on 3, that gives a cosine value of 1/2. So pi on 3 is one solution. And if we think about the symmetry of the unit circle, the other value that gives a half is going to be 2 pi minus pi on 3. So 2 pi minus pi on 3 is going to be 5 pi on 3. So we're starting to get a few solutions now for this equation. So we have x is equal to pi on 3 is one solution. Another solution is 5 pi on 3. And now we need to come and deal with the second equation, which is cos x equals negative 1. Now we know cosine is read off the x-axis, so we need this coordinate here, which is sine is 0, cosine is negative 1. And to get to there, we need to go pi radians around the unit circle. So the third and final solution for this equation is x equals pi.